Good morning. I'm Nick Hall. I'm the current president of Informs. I'd like to welcome everybody to this wonderful conference. And it's a great pleasure to see everybody here. And it's also a great pleasure to introduce the general chair of the conference, Jack Klober. So I'll give you a little bit of background about Jack. Jack is retired from the U.S. Army after a distinguished 23-year career as a lieutenant colonel, with experience in R&D portfolio management, decision analysis, modeling and simulation, technology selection, and strategy development. He taught at West Point, mathematics at West Point for 3 years, and graduate level decision analysis, system simulation, and technology selection for 6 years at the Air Force Institute of Technology. His work has supported decisions for various Superfund sites within the Department of Energy, many technology organizations within the Department of Army, Air Force, and Navy. After retiring from the Army, Jack was head of portfolio management for Bristol Myers Squibb, and more recently, head of portfolio management for Johnson & Johnson Pharma Services, where he coordinated portfolio management efforts across multiple R&D and marketing operation companies. He was a senior partner at Chromite consulting company for 5 years, and now has served 7 years as principal at Chromite. Jack led the consulting team who supported Syngenta and was a member of the Edelman Award winning team in 2015. So Jack received his PhD from Georgia Tech and MSIE and BSIE degrees from Lehigh University. So Jack is a past president and fellow of the Society of Decision Professionals, member of the Decision Analysis Society, and a 25-year member of Inform. So the amount of work to organize this conference is substantial over about a 10-month period. I've been talking about it with him, and he's done a wonderful job, and we're able to report record attendance at the conference for the first time, more than 1,000 people attending. So that's an enormous contribution to all of us and to Inform. So I'd like to welcome Jack to the podium.
Well, good morning, everyone. This is going to be fun. It's going to be a great 2 days, really kicking off the program content of our analytics conference, and I think it's going to be exciting. I'm really excited to introduce our keynote speaker. But first, I want to cover a little bit about some of the folks that have really made all of this possible. And unfortunately, we can't spend a lot of time on each name, but I would love to go into depth how each person helped, how they put in time and effort for free, their expertise, their network, everything else to bring all this together. First, we can't do much without our sponsors. Great sponsors. I won't read every one of the names. I'll leave these up for a few minutes, and they'll be flashing throughout our 2 days here because we really want you to know. Pass by the sponsors if you could, and really thank them for helping us put this on. Our gold sponsors. And our silver sponsors. Now we also have sponsors for ECPN, Early Career Professionals Network, and that was a great program we had over the last 2 days. And here are our sponsors for the ECPN. And finally, the Edelman, which is on top of everything else. What a fantastic program. That kicks off with all the presentations, the competition today, and our Edelman tonight. Our Edelman sponsors. This page is for the platinum level sponsors. Shows you how big the Edelman has grown. We have this many fantastic platinum level sponsors. Executive level sponsors. Thanks to all of them. And the champion level sponsors. So what I'd like to do before we start talking about the individuals that really helped put this on is I'd like to have a big round of applause for our sponsors. They're put in so much money and effort. Thank you. So the conference organizing committee is just, Nick said, so much work. Well, the work was, we ran some meetings and held some meetings every 2 weeks for the invited chair, and the selects chair had their meetings and gathered up all the submissions, and all these different committees met at their different schedules. So I was surprised sometime I'd find out what's going on here. Oh, it's all done. They've already finished all this, and look at the quality. And so it was just a magnificent effort. They really have this down to an art, actually now to a science. It was an art. So we're going to show some slides here. I can't have everyone stand up and receive applause, but first off, there's the organizing committee. These are the folks that we worked with day in, day out, and just did a fantastic job. They themselves would qualify for keynote speakers and are keynote speakers in other conferences. They're very, very distinguished people that have a great career going and have put their time and effort and their network in. So thank you very much to the organizing committee. The Selects Committee, over 100 papers, reading through them, organizing them, prioritizing them, and calling them up, finding out if they'd be good speakers or not, and cull it down to 30 speakers that will be speaking here today in the next 2 days. So you're going to see some outstanding speakers here, and a lot of that is because of the Selects Committee doing such a fine job. So headed up by David Leonardi, and we had to talk him out of retirement to do that, and we thank him, and thanks everyone on the Selects Committee. Poster committee, and with a big reminder down the bottom, don't forget the poster committee. Actually, in Las Vegas, it was a little bit harder to find, but here it's going to be right there, right where everyone can see it, where you're looking at all the exhibitors that have come in. It's going to be very close, and so we hope everyone, we're putting 28 new posters up each day. What a great way to spend 5, 10, a half hour, an hour, just perusing there, finding something of interest to you, or to your students, or to your company. So thank you, Alan Tabor, and you've done a fantastic job in organizing that. Thanks. And the early career professional, we already talked about that. A lot of good volunteers, so nobody has to do everything. Headed up again by Alan Briggs and Xingping and Shrikant. They've done a great job and really organized it. It went well all yesterday and the day before. So thank you very much to the Early Career Professional Committee. And you may want to write down these names if you have some ideas of people that would qualify for Early Career Professional that can participate. It's a great meeting they have where they get to share problems they had. They bring in senior folks, they bring in junior folks, they bring in just graduates, and they all talk about what problems they had, solutions, opportunities. These are all the participants. So today we're going to have a first of our 2 plenary speakers. Bill Schmarzo will say a little bit more about Bill in a minute, and Bruce Greenstein will be talking tomorrow morning. We really wanted to have one corporate speaker, one speaker from corporate America or big business to talk about analytics and big business, and we really wanted someone from the public sector. And we hit a home run, I think, on both accounts. So I'm excited about both speakers. We'll talk a little bit more about Bill in a minute here, but tomorrow Bruce Greenstein will be here to talk from HHS, which I found out was the largest government agency in the world. All right, there's some special events, just to bring them up so you can take note. Anywhere from the Edelman competition, which you've seen signs around, through the student competition, Syngenta Challenge, the Caterpillar Challenge of IAAA, George T. Smith Prize, networking lunch. So please quickly read through there. You might be surprised. There's some things going on in these next 2 days that maybe you didn't know about. And now what I'd like to do is get to our the main event today with Bill Schmarzo. Well, I was lucky enough to meet Bill Schmarzo through a friend of mine, Joe Byram, who I asked around to all the folks that I thought would know. And Joe's first name out of his mouth was, yeah, Bill Schmarzo would be a great keynote speaker. So way back in August, we contacted contacted Bill, and he was just glad to accept. And I was thinking, wow, this is going to go great. Way back in August, we already have our first keynote speaker, and this is going to be smooth. There were some other parts that didn't go too smoothly, but this part went very smooth. Bill is currently the CTO of Internet of Things and Analytics for Hitachi Vantara. He recently came from Dell EMC as the CTO. He has a really interesting list of companies that he has worked for as VP, including Yahoo as VP of Advertising and Publisher of Analytics. Also, he started out with Accenture, or Anderson, as we were talking about way back in the 70s. But first he started as a math and computer science major from Coe College, and then got his MBA from University of Iowa. And has done other work on boards such as Board of Advisors with Data RM, and he's on the City of San Jose Innovation Advisory Board. I won't go through all of the great companies that he has worked for as vice president either of marketing analytics, big data. You couldn't write a better resume for someone who's going to talk to this audience. So I promise I won't take too long introducing Bill. We could go on, but I would like to say that he's probably one of the more interesting people to follow on LinkedIn. On LinkedIn, you find so many comments, not just reposts, but original content from Bill out there asking people for comment. What do you think about this? Should we change this? Is this possible? What can we do about this? He's just a great person. If you're not already linked in with Bill, I would get linked in with Bill. Very interesting. So without further ado, Bill Schmarzo, welcome.
Thanks. Thank you, Jack. Good morning, everybody. What I'm going to cover today in the tick 48 minutes that I have is I also teach at the University of San Francisco School of Management, and I teach a class called the Big Data MBA. And in that class, we are trying to teach tomorrow's business leaders to embrace analytics as a business discipline. Now, this is very different than I think for many of you out there, is that there's a generation out there, a generation we tend to put down, the millennials, who don't think of analytics as a bolt-on to their career, which is what most people think about analytics, right? I'm in the retail space and I also do analytics. I'm in the healthcare space and I also do analytics. No. This generation does analytics. They just happen to be in different industries. And so the mindset is very different. The whole frame of how they approach things are very different. And so I'm going to take you through that class. I've got to try to condense a whole semester down to a short speech here. But we're going to go fast. We're going to go rapid. Take pictures. You can tweet this stuff if you want. But we're going to talk about what's required, what's necessary for business executives and IT executives to start thinking like a data scientist. And the whole process starts with how you frame the conversation. I can't tell you how many conversations I have where somebody says, I need a big data strategy. I need an IoT strategy. I need a digital transformation strategy. It's like, are you kidding me? No, you don't need a big data strategy. You need a business strategy that exploits the value of big data. You need a business strategy that exploits the power of data science and machine learning and deep learning, right? That's what you need. You got to focus on the business. This conversation starts with the business because it's about the business. The single most important question I ask my clients when I get involved, very first question I ask them is, how effective is your organization at leveraging data and analytics to power your business? Write that down. There might be a test later on. Remember, I teach, right? I might come back there and ask somebody back, say, hey, what was that first thing I asked you to write down, right? So write this down. I want you to think about it from your organizational perspective. Is how effective is your organization at leveraging data and analytics to power the business? I don't see pens moving. And because when I ask this question to companies, most companies look at me like I got lobsters crawling out of my ears. Like, well, I don't know. Right? They don't know. They don't know how to address that question. So we created this big data business model maturity index. It's a maturity index of how effective you are at leveraging data and analytics to power the business. It's not how effective are you with TensorFlow or Hadoop or Kafka or Lyota, right? It's not about the technology. It's about the business. And what we find, by the way, when we talk to organizations, they tend to sit along one of 5 different points along this maturity model. Right, so this model is useful because it helps organizations, number one, to figure out where do I sit with respect to others from a best of breed perspective in leveraging data and analytics. And once I know where I stand, it provides a guide for how you become more effective. And I'll tell you right now that most organizations, and I bet if I went through and did a survey right now, at least 90% of you haven't gotten past using data and analytics to tell you what happened. You got dashboards, you got reports, that's great, but you're not predicting, you're not prescribing, you're not preventing. And so this model, this big data business model maturity index is designed to help organizations move from an environment of where you're monitoring the business to one where you're leveraging predictive and prescriptive analytics to optimize the business. You are making humans more effective in their decision making. The fourth point here is very interesting, the whole monetization conversation. Notice it doesn't say data monetization, because I think data monetization is BS. No one cares about data. In fact, most organizations think data is a cost to be minimized. Data gets no respect. They're the Rodney Dangerfield of the IT industry. Right? They get no respect. But it isn't the data you're going to monetize. It's the insights. It's insights about your customers, your products, your services, your operations, your markets, your partners, your channels. It's the insights. It's finding those unmet needs out there. This is the heart of digital transformation, the monetization phase, because that's where you're going to search out new sources of value creation, and you're going to transform your business to optimize your engines of value capture. Digital transformation is about identifying sources of value creation and then optimizing the engines that capture that. In many cases, you're going to turn your existing organization upside down. You're going to stop paving the cow path and realizing that sometimes you have processes that don't need to be optimized but need to be thrown away. Because the technology coupled with the insights you have about your customers, your products, and your services are going to allow you to trash things. Think about how I order Captain Crunch today, right? When I wake up in the morning and I go to my pantry and look for a box of Captain Crunch and it's not there, panic sets in. Right? Panic sets in. So my old model was, put my clothes on, hop in the car, fight traffic to the grocery store, park it, try to find a stupid cereal in the store and then stand in line to pay for it and drive home. What do I do now? Hey Alexa, 2 boxes Captain Crunch. That's not optimizing a process. That's totally disrupting it. And you do it because of the insights you have about your products, your customers, and your services. If you believe, by the way, that this is what organizations are capable of, if this is what your organization could do, and I can guarantee you any organization can do this. And in fact, I would argue, I can't have enough time today, but I would tell you that I think that your commercial accounts versus your enterprise accounts have a head up in this area. They have less baggage. They have less to carry around. But if you believe this is the what, then this is the how we do it. This is part of a process we teach at University of San Francisco called thinking like a data scientist. And what it is if you're trying to drive the business, you're trying to be meaningful and impactful on the business, then it's probably best to start with the business. Start with what the organization is trying to accomplish. Hospitals might be trying to reduce readmissions and hospital-acquired infections. If you're in a commercial retail space, it might be about customer acquisition, retention, fraud, right? Your company has business initiatives. And those business initiatives are wonderful and great because there's one thing typically associated with them. Even if you're a nonprofit. Money. Money. Your business is about making money, right? It's not about the 3 V's of big data. It's not about volume, variety, and velocity. It's about the 4 M's of big data. Make me more money. So let's start with the money. And so what we do is we figure out and start with a business initiative, and then we identify the business stakeholders who either impact or are impacted by that initiative. And then the secret sauce to this whole process, the thing that makes this go, the single one word I want you to remember, a second word, you're going to remember 2 words from Schmarzo today. Number 1, decisions. Big data, data science, optimize decisions. And the reason why decisions are powerful, because every business stakeholder I've talked to in the past 30 plus years I've been in this thinking industry knows what decisions they're trying to make. We've been trying to make them for decades. What's changed, we now have more data, and we got better tools, and we got these data scientists with their big giant brains who know how to optimize decisions. In order to power the business, in order to optimize key business processes or operational processes, the business stakeholders and the data scientists must work together. And you need to teach the business stakeholders how to think like a data scientist, how to brainstorm the analytics you might want to use, what data you're going to use to help drive that. Decisions are everything. By the way, not all decisions are of equal weight. You're going to have to spend time identifying, validating, vetting, valuing, and prioritizing the decisions. It takes time. It takes effort. You don't just step into it willy-nilly. The reason why you want the business involved, because they're the ones who best understand what decisions are most important when, and what decisions can wait till later. And then once you've gone through this process of identifying the decisions, the analytics, and the data, oh, by the way, now I can tell you what technology you need. But where do most organizations start? Technology. We're going to do IoT. Okay, I'm going to go out and buy a bunch of IoT gateways. What are you going to do with them? Well, I don't know. I'm going to go out and buy them. I'm going to go get Lyota. I'm going to go get Kafka. I'm going to go get TensorFlow. I'm going to go get all this great stuff. What are you going to do with it? I don't know. We're going to go get it. Google's got it. GE's got it. Right? They've got it. No. You got to know what you're going to do with this stuff. By the way, this process is really simple. This is really simple. And this conversation, by the way, must be kept simple if we're going to make it actionable. We spend too much time complicating this conversation, when in reality, it's very simple. It's simple. We're trying to optimize decisions. All right, let me jump in here. I'm on schedule. That's really rare for me. That's good. I haven't got any warning signs yet. Keep it down. Don't want to show that yet. So why is big data an important part of this process? Well, we know all the interesting factoids, right? That we're leaving our digital fingerprints all over the place. 1 billion people today had their data stolen on Facebook. So we all know this stuff, right? That was kind of a joke. Only kinda. Right? So we know there's a whole bunch of data out there, and we know that IoT is going to create even more and more data. We've all seen the prognostications of how we're going to be overwhelmed. We're going to have 44 zettabytes of data. You know what's after zettabytes? Is yottabytes. And I'm guessing after yottabytes, it's Darth Vader bytes, is my guess. I'm not sure who names this stuff, but doesn't make any sense. It's just, as we say in Iowa, a whole shootload of data. Notice I corrected my words there, right? Whole shootload of data. But what's interesting about what's happening in big data, and why I believe the next generation is better suited for this than maybe many of us are, is because every day they live with the ramifications of what organizations are doing with big data. And what they're doing with big data is they're making recommendations. They're recommending products, books, routes, movies, songs, spouses, right? They're recommending all these things based on what they know about you. And what's interesting about big data, in order to do this, which, by the way, anybody can do. Any organization out there can deliver recommendations to their customers to make those customers more successful, more fulfilled, but it requires a very important concept. And that concept isn't about big, it's about small. You want to build detailed profiles on each of your customers. You want to understand their tendencies, their inclinations, their interests, their passions, their affiliations. You want to know so much about your customers, what they're trying to accomplish, so you can help them to accomplish it. That requires getting small. This is not 360-degree view of customer, which is a BS statement. This is about having the insights as to what they like to do. Schmarzo likes Captain Crunch. Amazon knows that. Amazon knows it so well that they got it pre-stocked out in a distribution center at 94301 zip code. So when I order, it shows up within the same day, and soon, because courtesy of drones, it'll probably be there in 30 minutes. But it isn't just humans that have these tendencies. So do machines. Wind turbines, cars, jet engines. You can build this is a concept called digital twins. We're building very detailed profiles so I can figure out when do I need to perform maintenance on that wind turbine, what kind of maintenance am I going to do, and how do I schedule it, and how do I load balance between all those other wind turbines in that same wind farm. What assets do I need? What inventory? What materials? Right? Predicting based on what I know about each individual wind turbine or car or CAT scan machine or pacemaker. This is an important concept. We're going to come back to this in a second. It's not about big, it's about small, it's about the individual, it's about learning their tendencies. Let's talk about what data science is. Now, I get a lot of questions because I teach about, hey, Schmarz, what's the best data science book to read? If I had to read one book about data science, what book should I read? And I say, well, other than my book, of course, the book I recommend, book, not the movie, is Moneyball. How many people in here have read the book? Good, good. I love, by the way, movie doesn't count. My wife went and saw the movie. I said, well, what'd you think? She goes, oh, Brad Pitt, he's so cute. I said, what about on-base percentage? What about on-base percentage? And what I love about Moneyball is that they take some fairly complex data science concepts and bring it to life. And I love how they depict data science. Write this down. Data science, or take a picture and tweet it, we don't care, right? Data science is about identifying those variables and metrics that might be better predictors of performance. Period. Scrap that 400-page book on data science, because this is all it is. We're trying to find variables and metrics that might be better predictors of performance, and the key word there, which is not hard to figure out because it's actually in blue, is the word might. Because might is a license to try and be wrong. Data science is about mastering the art of failure. Learning to try things, failing at it, learning again and trying again. I love the book. Think about, for example, when you watch a baseball game, when the Orioles are playing or the Cubs, wherever your favorite team is, and you see the infield shift all to one side or the other. They're using an analytic profile that says that batter has a propensity to hit the ball in that location. Every batter has a profile. Can't hit the ball on the outside corner. Analytic profile. Baseball, Moneyball does a great job of bringing the concepts of data science to earth. It's not complicated. Stop overcomplicating this conversation. Remember this definition. We're going to come back to it in a second. What we want to do is we want to leverage data science to really accelerate up the value chain. To go from asking questions about what happened to predicting what's likely to happen in order to take prescriptive and preventive actions. That's the value chain. There's little value in asking questions. Right? I would actually, there's no value in asking questions because questions aren't actionable. Decisions are actionable. And ultimately, I want to be able to get to decisions that are going to drive actions. I want to go into actions. Now, the classic BI way of doing things, and I was in the BI space for 25 years before I went to Yahoo and had to unlearn everything I knew about data and analytics. Yeah, my journey at Yahoo started with unlearning everything that I thought I knew about data and analytics. We had a project for advertisers and the agencies to help them optimize their spend across the Yahoo ad network. We called the project Looking Glass. It was based on an Alice in Wonderland sort of experience. We wanted to transform how these people leverage data and analytics. But the person who went through that looking glass was me. And I had to unlearn this model so I could learn this model. This is a model that's based on fail fast, learn faster. I need an environment where I can ingest data very, very quickly. I can explore, I can test. I can't measure cycles in weeks or months. I can't build a data warehouse star schema that takes me 2 months because by the time I get the stupid thing done, the question's already happened. The storm in Houston's already hit, right? Or the opportunity, the Cubs winning the World Series, there's that blip, you can take advantage of it. I can't wait 3 months to take advantage of that change. So this is an environment that's based on fast. I bring data in fast. I don't build schemas. Well, at some point I'm going to build a schema when I start doing my modeling, but I'm going to build a flat file. For those of you who are techie, you know that flat files are horribly wasteful in storage. And I say I don't care because storage is free, time is not. Time is critical because the reason why this process is so important is because you're trying to predict what's likely to happen, so you're never going to be 100% accurate. Consequently, you have to fail enough times with the model so that at some point you feel maybe not confident, but at least comfortable with the model results. This is a process that should be measured in hours or days, not in months. And this process is really hinged around step number 5 and step number 6, where I'm quantifying cause and effect. I'm trying to measure goodness of fit. It's a fast process. Bringing data in, I want to see the impact that Zillow might have on student performance in class. Actual test we did for a project in education. What is the impact on the pricing change of the parent's house on the child's performance in class? Grab the data, bring it in, test it, figure out, look at it. Made that analysis in less than a day. By the way, there's no relationship. There isn't. But you know what? We learned. We learned that there isn't, and now we have that data available to test other ways. Let me give you my take on advanced analytics. I'm going to tell you right now, as we walk through these slides, I want you to remember the definition of data science. Data science is about identifying those variables and metrics that might be better predictors of performance. Drink of water for theoretic effect here, right? This definition is not right, because no definition is right. This is my take. This is what I teach my students. So number 1, the basic foundation of all analytics, I'm sorry, but it's stats. It's stats. I know you hate it, don't want to do stats. That was probably the second book you sold when you got out of school, right? You couldn't get rid of that thing fast enough. I'll take a bottle of beer for it, will you please? So, but it's important because statistics are what we use to quantify cause and effect and measure goodness of fit. You don't have to learn it all again, but you have to get familiar with it. You have to become familiar with stats. I'm not going to make you do stats, but you need to understand a lot of the concepts. This is the foundation, because upon this foundation, then we're going to lever some really interesting, more advanced technologies like deep learning, aka neural networks, and machine learning, both supervised and unsupervised. Now, the key thing about these things is what these technologies do is they try to identify variables and metrics that might be better predictors of performance, right? They look for relationships, right? Now, deep learning, for example, identifies things, and that all-important decision when you're in getting your blueberry muffins, right? What's the difference between a blueberry muffin and a Chihuahua puppy? Right. The flavor, thank you. Right, because if you're standing in line to get a blueberry muffin, you certainly don't want to grab a Chihuahua puppy by accident. They don't taste nearly as good. The flavor isn't nearly as good. But all deep learning is doing is trying to identify a variable that might be a better predictor of performance. And machine learning, both supervised and unsupervised, is trying to find known or unknown relationships that might be better predictors of performance. You don't need to know that there are 50 different neural network techniques out there. You don't need to know that. My data scientist does. All I need to know is it can tell me what's a Chihuahua puppy and what's a blueberry muffin, or how long somebody's been standing in line at a Starbucks, or who might be carrying a gun, and flag it and automatically alert somebody. That's what it does. It recognizes things. It measures things. The nirvana is where we're building this learning organization, a learning organization that's intelligent. And by the way, I almost struck a line through the artificial intelligence definition, because I still am not sure what artificial intelligence is. It's not, I can't write any code. I can do reinforcement learning. I can use Q learning to do reinforcement learning. So I'm going to talk about reinforcement learning. And I love reinforcement learning because what reinforcement learning does, very simply, it tries to maximize rewards while minimizing costs while playing a giant game of hotter and colder. You've all played hotter and colder, right? Your mom hides the Easter basket for you and Sunday morning, and she hit it too well and you can't find it and you start to cry. She goes, okay, let me help you. You're getting hotter, you're getting hot. No, now you're getting colder, now you're getting hotter, you're getting hot. That's all reinforcement learning does. Now, defining the rewards and the costs are really critical. Is very important. If you're doing autonomous vehicles, loss of life needs to be quantified pretty harshly. All right? So, by the way, a little fun fact. Because there's not enough humans driving enough cars, enough miles, in order to train autonomous vehicles, some companies are resorting to teaching their cars to drive using a game called Grand Theft Auto. How many people in here have played Grand Theft Auto? Yeah, I know how I play. I don't want a car that's trained by how I play Grand Theft Auto. So this is all it is. This is all, well, wait. It's even simpler than that. This is all it is. This is all you need to know about advanced analytics, right? This is all you need to know. In light of all we're trying to do is to identify variables and metrics that might be better predictors of performance. Simple. Keep it simple. Don't get bogged down and complicated. As you evangelize this across the organization, the challenge is not to make things more complicated. The challenge is to keep things simple and actionable. You bring this back to your organization. If you really want to become more effective at leveraging data and analytics across your business, keep the conversation simple so that it's actionable. What I'm going to share with you now is some research we just finished up last year at the University of San Francisco about determining the economic value of data. Now, I got to tell you, this is one of those life missions that I've been working on this, I bet you, for 10, 15 years. This is the white paper from hell. As I go from company to company, from laptop to laptop, it follows me. And last year, my co-teacher, Professor Sadawi, and I decided we're going to tackle this thing. And so we started talking to people about it. And I'm going to take you through the kind of a story here, because there was a lot of moments of unlearning for me in this process. And it started with this comment about data as currency. Data as currency is a phrase that was used quite a bit, but it isn't actually like other currencies. Think about, for example, you go to Starbucks, which is located over here, I believe, and you want to get a cup of coffee, and you give them $1, and you give them $5, and you get a cup of coffee back, right? It's transactionally limited, right? You give them the $5, bye-bye $5, you take the cup of coffee, and eventually, bye-bye cup of coffee. It's got a transactional limitation. You only can do it once. And the same thing, by the way, humans are considered a form of currency. So, here I am, keynoting to you. I'm not teaching. I'm not writing a blog. I'm not cleaning the garage, right? I only can do one thing at a time, and I sometimes don't do that very well as it is. Ask my wife about the garage. Data's not like that. Data doesn't have a transactional limitation. In fact, it has what we originally called a network effect. That you can use the same data over and over and over again at a near zero marginal cost. Never depletes, never wears out, and the same data set can be used across an infinite number of use cases. We called it a network effect, but in reality it wasn't a network effect. And by the way, what other asset do you have that has those characteristics? What other asset do you have on your books that never wears out, never depletes, and used across an infinite number of use cases? You don't have one. And it freaks out people. It freaks out the CFO. This is why organizations have struggled to put the proper amount of investment into data, because they don't know how to value it. Data is not the new oil. That's a bad analogy. Data is the new sun. never depletes, never wears out, can be used across an infinite number of use cases. And this network effect actually turned into be an economic multiplier effect. Okay, how many people here remember your economics, right? The multiplier effect. That, by the way, was probably the first book you got rid of when you got out of college, your economics book. But what's interesting is the aha moment for us in this process was that this conversation, this determining the value of data, wasn't an accounting conversation. It was an economics conversation. Let me go way back to the roots of this conversation, to Adam Smith, Wealth of Nations, 1776. In that book, yes, we read that book in my class. My students hate me. Adam Smith talks about value creation, about value in exchange, right? That something, an asset, is worth what someone is willing to pay for it. And our entire accounting system is based on value in exchange, depreciation schedules and balance sheets and things like that. But Adam Smith also talks about another concept, value in use. That is, what is the value of the asset based on what I can get from it, what it can help me do more effective. That's an economics conversation. And the value of data is not determined by accounting, where we've failed for years to put an accounting block value on this data. It's an economics conversation about how valuable I use it. For example, let's say that I got point of sale data, and I'm going to use that point of sales to improve my sales promotional effectiveness. And it's going to improve it by some percent. I say 2.5%. Maybe that's 0.5%. I don't care. It's going to improve it by some percent, and that improvement is worth something to the organization. Maybe it's $500,000. Maybe it's $50 million. Depends on your organization. But whatever it is, there's value associated with how you use that data to achieve that 2.5%. Oh, but wait, as I say in the Ronco commercial, there's more. Same data set at zero marginal cost can be used by marketing to improve customer acquisition. And again, there's some amount of value attached to improving customer acquisition. I don't know what the number is, but there's a number there. There's a number that can be attributed back to the data. And use case by use case, I start building the value from how I use the data. It's not an accounting conversation. Sorry, CFOs, it's an economics conversation, which is, by the way, when I am asked questions about what's the background for the ideal chief data officer, I say two things. First off, the title is the wrong title. It's not a chief data officer, it's a chief data monetization officer. Their job is to get value from data, and the background I want from my CDMO is an economics background, not an IT background. I got a whole organization full of IT people. I want somebody who has an economics background who can help me figure out what my data is worth. So we launched this project, and we had some aha moments. Number one, data silos and shadow IT spend are the great destroyers of the economic value of data. If the economic value of data is based on our ability to use it across use cases, to take advantage of the economic multiplier effect, data silos destroy that. Right? Shadow IT spend. By the way, I love asking this question. I go into a client. I want you to think about the answer to this question. You don't need to answer it for me. When I walk in and I say, so, do you have Salesforce.com? And most organizations have Salesforce.com. Raise their hands. I say, good. Great. Who brought it in? Exactly. The business, not IT. And so you have, I worked at a company, a very large company, that had 17 different instances of Salesforce.com. Brought in by the 17 different business units, and the data, sharing the data across that was friggin' nightmare. Right? Data silos and shadow IT spend are destroyers of economic value of data. We now have a way we can think about how we can codify what that costs the organization. I expected that, by the way. It didn't really surprise me. What did surprise me in the research was this concept of orphaned analytics. Some of the organizations we talked to were very senior, very far down that big data business model maturity index. They were using analytics to really power key operational processes and business processes, and they suffered from this thing that they called orphaned analytics, which is they would build these analytics, they would solve this problem on a one-off basis, and they would never operationalize it. So they get this sugar kind of rush, kind of a Krispy Kreme high from solving this problem, but they never found a way to package and reuse that one. That was a really tough challenge for us. I'm going to talk to you about how we approach that. So let's walk through an example. Oh, before I do that, no surprise, but the research showed us that the best way, and it's not the only way, I'm sure there's other ways to do this, but what we found is the best way to drive the economic value of data conversation is to focus it use case by use case. Identify, validate, value, vet, prioritize your use cases. You have to do that with the business, because if you know the use case will tell you what data I'm going to likely need and what analytics I'm going to likely need. It takes something that's this mesh of stuff I can't figure out, and it puts a structure around it. It puts a form around it. If I start use case by use case, I can drive and determine my data needs and my analytic needs. Let's walk through an example. So in my class, we do analysis on Chipotle. And there's two reasons. One, data is publicly available, and number two, I like Chipotle. I really do. I go there all the time. So it's an excuse for me to take my students to do some research. And so we look at the annual report, and the annual report is full of business initiatives, things the business is trying to do that has financial value. So we decided to focus in on increasing same-store sales. If we can increase same-store sales by 7.1%, which is a big jump, it's worth $191 million a year to the organization. I like that kind of number. I like numbers that have those big, lots of zeros behind them, right? And so what we did as part of the research at class, at least, is we go through and we brainstorm. Remember that thinking like a data scientist slide I had early on, where you have a business initiative and then you take the stakeholders and you brainstorm the decisions, and what happens is the decisions by stakeholder, you then group them and you end up finding out that there are a number of different use cases. For example, if I'm trying to increase same-store sales, I can increase same-store sales by driving foot traffic in the store through local events. I can increase shopping bag revenue. Hey, get double chicken, throw some guac on there, right? So there are ways that I can do. There are some use cases for help me to increase same-store sales. And what we want to do is to not only identify those, but we want to prioritize them. And my prioritization screen is not there, but trust me when I say that you're going to go through a process of prioritizing those use cases. Let me walk you through this process. Okay, so the first one, increase store sales through local events. If your Chipotle store is located across the street from a Little League field, you might want to know when they have Little League games. Or you're across from a soccer field or down from a high school. You might want to know when they have football games and basketball games and special events. Right? You might want to know what's going on locally. And if you know what's happening locally, you can optimize your local marketing to drive that foot traffic into the store. We did a calculation. We'd figured out there's 5 different data sources we were going to need in order to optimize that use case. So by the way, the use case we estimated to be worth $62 million a year. Ignore the dollar amount other than the fact that there is a dollar amount. Maybe it's only 6.2 million. Maybe it's only 620,000. Again, there's all kinds of financial analysts. My classes were full of financial analysts who could tell me what the number is, right? I don't really care what the absolute number is. I care that there's a number there. There's 5 data sources I'm going to need to support that, right? I'm going to need point of sale, I'm going to need market basket, local competition, social media, and oh, guess what? I might need to know local events. I might need to go out and get the Little League schedules and the soccer schedules and the high school football schedules, right? I might have to go get that. Those 5 data sources help me to achieve $62 million. My next use case number 2, is around increasing store traffic through a loyalty program, which we estimate to be worth $56 million. Again, the dollar amount doesn't really matter as much as there's a dollar there. I need 5 data sources. Oh, but wait. 3 of them are already in my data lake. Index, catalog, metadata management, linearity, all the things required, granularity, latency, all the things I need around my data to make it an asset. I already have it in my data lake. I didn't just throw it in there. Because those first 5 data sources were integral to the business, when they went into my data lake, they went in with all the things necessary to make that data as accurate and complete and as low a latency and as low a granularity as possible. Why? Because it's an asset to help me achieve $62 million. And if I have that, I can use 3 of those data sources over again. So I already have them. And you can start seeing what happens here is use case by use case. I start reusing data sources over and over again. This use case by use case approach is a great way to build a data lake literally based on ROI, because even as the project at the end here, the value gets lower, the cost, because I'm reusing data, starts to approach zero. And you don't need to be a math major to realize when your denominator starts to approach zero, what happens to the ROI of your project? Sideways 8, right? Sideways 8. Use case by use case, this process works, but it runs counter to two traits that most organizations, especially large organizations, have a hard time doing. Organizations have a hard time prioritizing, and large organizations have a hard time focusing. They don't want to do one at a time, they want to do them all. And the best way to guarantee you do none is to try to do them all. Simple. Couldn't be more simple. Your data lake becomes this repository driven by the ROI of the use cases. Analytics wasn't as simple. And the reason why the analytics conversation wasn't so simple was because I came in with the wrong mindset. I spent many times talking at events and to customers about data as curated data. That was a term that I had used. Curated data. But it wasn't. It really wasn't data. Let me explain why. So let's walk through an example. These are analytic profiles, or behavioral profiles, or digital twins, depending on your favorite term. This is basically a key value store for every one of my customers, my patients, my doctors, my engineers, right? Whoever my leaders might be. And I'm going to build out for every one of those key entities. It can be trucks, can be wind turbines, jet engines, right? I'm going to build out these behavioral profiles that capture the analytics. So for example, my first use case, remember, was around improving campaign effectiveness of local events. In order to support that, we know the 5 data sources we wanted. I needed to build analytics for each of my key constituents, each of my Bill Schmarzos out there, around their demographic segments and their behavioral segments. And by the way, the behavioral segments are much more interesting than demographic segments. I'd rather bet on what people do, not what people say they are. So I'm going to build these profiles, behavioral segments. And by the way, for you marketing folks, to think that a customer fits in one segment, one behavioral segment, shame on you. That is so 1985, hey, they're calling and want their fax machine back, right? People fall into multiple categories based on their behaviors, their frequency, how often, where do they go, how much do they spend, who do they go with? Think about the behaviors. Behaviors tell you so much more. I'll get off that soapbox. My second use case was around increasing customer store traffic through a customer loyalty event. Then watch this is really key. In order to do this, I'm going to create for each of my customers a customer loyalty score. It's like a FICO score, right? FICO has proved that we can do this, right? I'm going to create for every one of my customers a loyalty score. In order to do that, I need to improve my behavioral segment. So what do? I check it out, I modify it, and check it back in, and now it's version 1.1. Ooh, this is not data. This is not like data. Version control, check in, check out, regression testing. Starts to smell like software to me. Now what's interesting about this use case here, while I improve the accuracy of my behavioral segments by some maybe minor percent, because I needed to do that for my customer loyalty program, the use case that benefits from that improvement at 0 marginal cost is my first use case. My campaign effectiveness just got better. Maybe only 0.01% better, but I got it for free. And again, if the denominator is 0, the ROI is sideways 8. And so you can start seeing what happens here is that I start building out these analytic insights. And they're not like data, it's actually like software. And eventually you're going to have this repository, a key value store. Think you might use Jupyter notebooks and GitHub might be your way of doing it. There's actually tools coming out today and nowadays that actually help to operationalize this process. But analytics is like software. And we know how to write and treat software. And now we have a vehicle for allowing me, when I get into a brand new use case, not only do I have the data in my data lake ready to go, but I have a whole bunch of analytics already pre-built on each of my key entities. my customers, my students, my physicians, my trucks, my CAT scan machines, whatever it is, I can build these detailed profiles. I don't start from nothing. I got a foundation that I can reuse. Remember, the value is not value in exchange, it's in value in use. And how do I use this? Driven by use cases. So let me wrap up here. I laid up this chart. I asked you to write down the note about how effective is your organization at leveraging data and analytics. And I'm going to tell you that these 3 different types of analytics help progress us up that path. But you can't start with cognitive analytics or learning and things. You have to build out the insights about your customers, your products, your operations. Right? The data is of critical value. But having data today is not sufficient. How are you using it? How are you using it to power the business? How are you becoming more effective at leveraging data and analytics to power your business? Thanks for your time.